Welcome to CodingCraft. Today we're tackling Ocean View, a real interview challenge asked by companies like Amazon, Microsoft, and Google. Let's find out which buildings get to enjoy the sunset, and why. Here's the problem. You're given a list of building heights and a direction, either east or west. A building has an ocean view if all the buildings in front of it in the given direction are strictly shorter. Your task is to return the indices of such buildings in left to right order. For example, with the heights 3, 7, 8, 3, 6, 1 and the direction set to east, buildings at indices 2, 4, and 5 have an ocean view, since nothing taller blocks their line of sight to the ocean. Let's try the naive approach. For each building, we compare it with every other building in front of it, based on the given direction. If there's any taller or equal height building ahead, we skip it. This method is simple and correct, but it checks every pair, leading to a time complexity of O(n) squared. That's too slow for large inputs. There must be a smarter way. This solution is simple. Instead of comparing every building with all others, we just scan from the ocean side and keep track of the tallest building so far. If a building is taller, it has a view, and we add its index. That's it. Every building is checked only once, making it fast and clean, with time complexity O(n). Let's quickly recap what we've learned. Ocean view means all buildings in front must be shorter. Brute force works, but it's slow, with time complexity O(n) squared. A better idea is to scan from the ocean side with a greedy approach. If a building is taller than all before it, it has a view. We only tracked the tallest seen so far, and that gives us a clean O of n solution. Want more smart tricks like this? Check out the GitHub code, and don't forget to watch our next videos for more clean solutions.